Hey everyone, welcome to Chapter 9. We're going to start with 9.1 and 9.2, which is simple and compound interest, though the rest of the notes are going to be posted a little bit later. So first we'll start with simple interest. So when talking about interest, we should probably first start by saying that all it is a fee for when money is loaned or stored in a bank account based on the nature of how bank accounts work. This would be paid on a regular basis, such as once a month, or maybe it's just paid at the end of a loan. And interest can come in two forms, simple and compound. In the case of simple interest, all that happens is that the amount paid is just going to be a percentage of the original sum of money being talked about. So in some example, we might say that you owe $1,000 and there's a 5% simple interest rate, and that's going to be owed every month. What this means is you take 5% of $1,000, that's $50, and so every month you owe $50. And that would probably continue until you pay back the original loan. In this case, we'd refer to the $1,000 as the principal, which just means the starting amount, and we say that the loan has a rate of 5%. These terms are specific not just to interest, but in finance in general. There's a formula for computing interest. In this case, we can just say it's principal times rate times time. So remember our $1,000 example. Well, that would just be 1,000 times 5% times the length of the loan. The total amount, which is not the same as just the interest, because the interest is just the additional fee, is just going to be the principal plus the interest, which should make sense. And that you can compute as principal plus principal times rate times time, which is actually just principal times 1 plus rate times time, and that's here. So here, A actually stands for accrued amount, which just means total. This is a standard in finance, so when you see the symbol A in any formula, that just means total. Ask finance people why that's the case. I honestly don't know. For this formula to make sense, by the way, the unit of time has to match up with the rate. So if I say that it's 4% a year, time is going to be measured in years. If I say it's 4% a day, then time is measured in days. Often, in fact, pretty much almost always, time is going to be measured in years. So let's look at a really simple example. Gabby buys a bond from the city for $500. It pays a simple interest rate of 3% for 7 years. The way bonds work in real life is that you buy them for some set price. They pay you a simple interest rate of something for some specified amount of time, and at the end of that time period, you get your original money back. It's a way of somebody like the city getting money now so that they can pay it later, so they can fund things. In our example, however, we can ask, how much money is Gabby going to make in just interest? And remember that formula before, it's interest equals principal times rate times time. And in this case, that's going to be 500 times 7 times 3%, or 500 times 7 times 0.03. Remember, when you're doing these percentage calculations, the 3% is just 0.03. So move the decimal place over 2 places to the left, and you'll have converted. And that, by the way, is just $105. She didn't make a ton of money, but then we can ask the question, how much did she get in total? And, well, you can use that formula if you want, but if you remember, it's just the principal plus the interest, so that's just 500 plus 105, which is $605. Let's look at a different example. Mark wants to borrow $150 from Gabby, and he promises to pay it back in half a year with a interest rate of 5%, and that's an annual rate. Annual, if you weren't sure, just means once a year. How much interest is Gabby going to make? Well, we get the same exact formula, and we can say that interest is 150 bucks times 5% times 1/2 a year, because remember, we're thinking about the interest rate in years. Well, that's 150 times 0.05 times 0.5. And that's it. And that's just $3.75. Gabby's not going to make a ton of money, and she has to wait 6 months to do so. But, Mark's a buddy. Now, one of the things we can do is instead of thinking about what the interest rate is or what the total amount is, we can actually think of a slightly different problem for our last example. Larry's loan offers a special offer where they'll lend you $900 for 2 months and they charge exactly 50 bucks in interest. Now, the thing is we can ask the question, what's the annual interest rate of that loan? So we know what the interest is, but we actually want to know what the rate is. So since interest is just principal times rate times time, we can actually plug the values we know and solve for the rate. So in this case, we know that we have a $50 interest, we have a $900 principal, that's the amount they're loaning you, times the rate, which we don't know, times 2 over 12 years, because there are 12 months in a year. And, well, we just simply do some combining, and we say 900 times 2 over 12 is 150. And then we divide both sides by 150 to get the rate, and that's a third, which is 0.333333 forever, or 33%, or more specifically 33.333333%. And that's our annual interest rate. Keep in mind that this strategy isn't specific to just calculating what the rate is. You could have also asked how long was the loan if I knew what the rate and the interest was. So, on to the next thing. So, we're going to be talking about compound interest. Compound interest is the idea that when you get interest, we keep that in mind for when we get more interest. So your interest collects interest, which is kind of nice. It's better than the simple interest case when you're the one getting the interest, and it's worse when you're the one paying it. So we'll give an example. Say you have a bank account, it's got $1,000 in it, has 10% yearly interest rate. That's really good. And that's compounded once every year. So in the first year, that's 10% of $1,000, which is $100. So we add that to the $1,000 and we get $1,100. In the second year, well, we get 10% of $1,100, which is $110. So that's $1,210. Third year, you get 10% of $1,210, which is $121. So you make even more money with $1,331 in total. The thing that you can see here is that the longer it lasts, the more value you get from it. Your interest gets interest. Now, we should briefly mention APR, which is to say that when we talk about this, we're referring to the annual percentage rate. So when we're talking about compounding like 5 times a day or 200 times a year or whatever, this is done so that I don't have to constantly change what the time is in any of these formulas, and I can easily compare stuff. But it means that if a loan is compounded more than once a year, well, the percentage is going to be the APR, but that means we're going to have to divide by the number of times we compound. So if we say that you offer 6% interest and we compound every month, then you're actually only going to earn 0.5% every month. Don't worry, it adds up to 6%. It actually adds up to slightly more. but it doesn't mean 6% a month, it means 0.5% a month. So let's look at the formula though, because we don't want to calculate the interest every month one at a time. We've got formulas, so we can put them into calculators and make our lives easier. In this case, we've got A equals P times 1 plus R over N to the power of N times T. Now, what does all that mean? Well, A is the accrued amount. Remember, that's just the total. P is the principal, and that's the amount you start with. You should know what 1 is. N is the number of times we compound in a year. R is the APR, or the rate. And T is the number of years. Again, for practice, we'll give a few examples. So, say Paul has 200 bucks in an account with an APR of 6%, and this is compounded monthly. After 18 months, how much money is he going to be? So, our formula, once again, is A equals P times 1 plus R over N to the power of NT. So we plug in our values, we get 1 plus 0.06 over 12 to the power of 12 times 18 over 12. And yeah, I know that looks messy. That simplifies a little bit to 200 plus 1 plus 0.005 to the power of 18, which again, this should all be plugged into a calculator and not done by hand. This is about $218.78. I say about because you will have to do some rounding. When doing rounding in these examples, round at the last moment. Don't round in between because you can come up with some minor errors which lead you to get a slightly different answer. So plug in really, really long values into your calculator, or if you have a calculator that actually saves the previous value, just use that. So we're going to do an example 4 different ways. Where your account has $1,000, you've got 5% APR, and we'll ask how much are you going to have at the end of the year, or at the end of 2 years. And we have simple interest, compounded yearly, compounded monthly, and finally compounded daily. In the simple interest case, that's 1,000, and we just multiply that by 1 plus the rate times time, and that gets us $1,100. If we compound yearly, remember that we have to say 1,000 times 1 plus, instead of the rate times time, we have the rate divided by the number of times compounded a year, which is just 1, to the power of 1, because that's the same number, times 2, the number of years. And we'll get $1,102.50. If we compound monthly, that lower 1 and that upper exponent 1 turns into a 12 because there are 12 months in a year. Everything else stays the same. And we'll actually get $1,104.94. And finally, because there are 365 days in a year, we're going to say that compounded daily, we just switch that 12 to a 365, and we get $1,105.16. Again, this should be plugged into a calculator. Do not try to do any of these by hand. These numbers are really awful. But that's okay. That's what calculators are for. And remember, round to the nearest cent. Don't round to the nearest dollar, unless the question asks you to. For the last example, we'll switch things up just a little bit. And we'll say that Kate has access to an account. It's got 3% APR, and it compounds semi-annually. Semi-annually just means twice a year. She's going to deposit amounts of money that we'll worry about in a second. And 5 years later, she actually discovers that she's got $50,000 in the account. And the question is, how much did she actually put into the account? What is that unknown sum of money? Well, remember the formula is just A equals P times 1 plus r over n to the power of n times t. We can plug in the known values and then just solve. So we'll get 50,000 equals p times 1 plus 0.03, because that's the rate, divided by 2 to the power of 2 times 5. Remember, the 2 is because it's semi-annually, that means twice a year, and the 5 is because it's 5 years. Now, all of that is going to get you a weird number on the right side times p. We're going to divide by that value, which is 1.1605408, so on and so forth. And that gets us $43,083.36. So that's how much money Kate put into the account, which means that she made $7,000 in 5 years just for having it sit there, which is why people like interest. And that's it. I know that that was pretty short. I'm going to be posting notes for the other sections soon. Make sure to do the homework now rather than later. Some of the later stuff can get kind of tricky, so if you do the first 2 sections now, uh, you'll have more time to work on the later stuff, so you don't have to panic. And by the way, I've posted a formula sheet in Canvas, which has this formula, or it has all the formulas. It doesn't have any extra labels or anything, but just use that. We don't want you to memorize all of these symbols and whatnot. If you were working in any kind of industry with finance, you would have access to those formulas. So why would I take them from you now? If you have questions, though, about this or other sections, and I will be happy to help. Those are my office hours. There's not a whole lot more to say, except I do want to say that this section is a little bit tricky, but it is kind of more practical than the other 2 chapters have been. It turns out that finance is something that you'll probably have to deal with in your life, hopefully in a positive way, and understanding how some of this stuff works might be helpful. Either way, have a great day.